Grade 9s, welcome back to our lessons on chemical reactions. Today we are going to do lesson 4, where I'm going to teach you how to write balanced equations for reactions. So basically, in the next few videos, we will teach you how to write balanced equations for reactions using the ball diagrams as well as symbols. So the first one, I'm starting off with the easier one, is hydrogen and oxygen making water. Now here we need to remember that hydrogen is a diatomic substance. So when I use ball diagrams to represent the reaction between hydrogen and oxygen, and I will use two balls clinging together for the hydrogen molecule, and the oxygen atoms are bigger than the hydrogen atoms, so we will draw bigger balls to represent the oxygen atom. You could use a different colored pens, or you could shade the different balls to represent the atoms like this, like I'm doing. So oxygen together with hydrogen, they are diatomic elements. So two oxygen atoms will cling together in an oxygen molecule. Water has an oxygen atom with two hydrogen atoms that has joined up to the oxygen. Some people say that it looks like a little bear. The two hydrogen atoms are like the ears of the bear, and the oxygen is the face. Now, we must also remember that you cannot create or destroy matter. So, if I look at this, I've got on the right-hand side one oxygen atom, and on the left-hand side two, which is a problem. So we need to solve the problem. And what we do is on the product side of the arrow, we draw another oxygen atom. But on the product side of the reaction, we can only have water molecules. So the oxygen must have formed bonds with two hydrogen atoms. Now, the oxygens are balanced. As you can see, you've got two oxygens on the left-hand side of the arrow and two on the right-hand side of the arrow. Unfortunately, our hydrogens are not balanced, but it's easy to balance. All we need to add is another molecule of hydrogen. Now, we've got 1, 2, 3, 4 atoms of hydrogen on the left-hand side, and we've got 1, 2, 3, 4 atoms of hydrogen on the right-hand side of the arrows. In terms of symbols, hydrogen reacts with oxygen to make water. Now, we could use the ball diagrams to write a balanced equation in terms of symbols, but we could also close up the ball diagrams and do it in another way. So doing it in another way, I'm going to distinguish between the reactant side and the product side by drawing a little squiggly line under the arrow. So as it is, we've got hydrogen and oxygen on both sides of the arrow. And what I'll do initially is write down how many atoms of hydrogen I have next to the hydrogen, and how many atoms of oxygen we have next to the O for oxygen. On the other side of the arrow, I will do the same. So 2 atoms of hydrogen as it is, and 1 atom of oxygen. Now, the one atom of oxygen needs to change to 2 atoms in order to have the equation balanced. Now, to balance it, I need to make 2 atoms of oxygen, we need to multiply the hydrogen with a water molecule by 2. If we do this, we would have 4 atoms of hydrogen and 2 atoms of oxygen. The 4 comes from 2 times 2, which gives you 4 atoms of hydrogen, and 2 times 1 oxygen would give you 2 oxygens. We can't put the 2 for the oxygen there like that, because the molecule for water has only got 2 hydrogens and 1 oxygen. So we have to multiply the water molecule's formula by 2, which makes sense if we look at this situation here where we use the ball diagrams to write a balanced equation, and that is where that 2 comes in. Okay, so we've got 2 molecules of water forming. Now, if you look at our situation here, we have 2 hydrogens and 4 hydrogens on the right-hand side. So we need to balance the hydrogens now. To balance the hydrogens, what I'm going to do is I'm going to multiply the hydrogen molecule by 2. Multiplying the hydrogen molecule by 2, we would change the number of atoms hydrogen to 4, and oxygen is still 2. So now I can check myself. 4 hydrogens on the left-hand side, 4 hydrogens on the right-hand side, 2 oxygens on the left-hand side, 2 oxygen atoms on the left-hand side. So that would be a balanced equation for the reaction between oxygen and hydrogen to make water. Something else I would like to add in here into the symbol equation is the fact that we indicate the state of the substance. Like hydrogen is a gas, and I write in brackets a little g after the formula for hydrogen. Oxygen is a gas, so I write a little g after the formula for oxygen. Now, when water forms in this reaction, it would be water vapor because the temperature is much higher than 100 degrees Celsius, which is higher than the boiling point of water. So water molecules, when they are formed in this reaction, will also be a gas. Now, it is a good habit to write down the ratio between each of the substances. There would be 2 hydrogens reacting with 1 oxygen to form 2 water molecules, and you must be able to write down that in words. So 2 molecules of hydrogen reacts with 1 molecule of oxygen to form 2 molecules of water. And if you use the method I showed you in a previous video to calculate the mass of the reactants and the mass of the products, you would see that matter is conserved during the reaction. The next reaction we will look at is potassium reacting with oxygen to make potassium oxide. So, potassium is an element in period 4. So, potassium's atoms would be much bigger than oxygen's atoms, because oxygen is an element in period 2. You may have your periodic table open as we go through this work, so that you can make a reference to it. Oxygen is also diatomic. Now, not to make silly mistakes in this, I need to remember that potassium is in group 1, so it's got a valency of 1. And oxygen is in group 16, so it's got a valency of 2. For us, in order for us to understand the formula for potassium oxide, I must know that potassium can form 1 bond and oxygen can form 2 bonds. So if we have oxygen, it can form a bond with 2 potassium atoms. And this is how we represent it in terms of ball diagrams. So I see that on the left-hand side of the arrow, we've got 2 oxygens. On the right-hand side, we've got 1. So we need to add another oxygen to the right-hand side. If we do that, it must come with 2 potassium atoms joined to it. Right. So now the number of potassium atoms, or the number of oxygen atoms would be 2 on the left-hand side, 2 on the right-hand side. But we have changed the potassium atoms. You've got only 1 on the left-hand side, and you've got 1, 2, 3, 4 on the right-hand side. 1 on the left-hand side, 4 on the right-hand side. So what we need to do is we need to add 4 more potassium atoms on the left-hand side. Now, the number of potassium atoms would be balanced. In terms of symbols, the symbol for potassium is K. The symbol for oxygen is O, but it's diatomic. And the symbol for potassium oxide, you have 2 potassiums joined to 1 oxygen. If you want to take the slow route first, draw a squiggly line below the arrow, write down the symbol for each of the elements in the reaction on both sides of the squiggly line. Then write down the number of atoms you have of each element. So we've got 1 potassium and 2 oxygen atoms on the left-hand side, and you've got 2 potassiums and 1 oxygen on the right-hand side. To balance the equation, I want 2 oxygen atoms on the right-hand side for it to be the same as the 2 oxygens on the left-hand side. So we need to multiply potassium oxide by 2, then we get 4 potassium atoms. To get 4 potassium atoms on the left-hand side, we need to multiply the potassium by 4. So there we have a balanced equation for the reaction, and the ratio is 4 to 1 to 2. 4 potassiums to 1 oxygen to 2 potassium oxides.